backtracking. This time we're going to look at some pictures and some real-life equations. Looking at these ladders, can you explain why the rule for the number of toothpicks n in a ladder with r rungs is n equals 3r plus 2? We'll look at the ladders. The rungs are the things that are in the middle here. So this is a rung, this and this and this and this and this. How would we explain this? What does that mean? Well, the 3r means for every 3 toothpicks, I have one rung. If you look here, I have 3 toothpicks, 1 rung, 3 toothpicks, 1 rung, 3 toothpicks, 1 rung. So I would explain that as every 3 toothpicks, I have 1 rung. Also, you can see at the top, I always have 2 extra at the top. Think of a ladder. You have to lean it against something. We always have those 2 at the top. So write that in your own words, how would you explain that? Now, use that rule that they've given us to say, what would I do if I had 110 toothpicks? Well, the rule was n equals 3r plus 2. Now, use our substitution. Put in 110 for for n. 110, that's the toothpicks, equals 3r plus 2. Use your backtracking to solve. Here we go. I have 3 circles because I have 3 numbers. Remember, we talked about that in class. Now, first thing I do is times 3. Then I add 2. That's what I'm doing to the variable. Now, undo it. I got to 110. Undo that. Subtract 2 gets me 108. Divided by 3. 8 doesn't look very well, but we'll divide that by 3. Gets me 36. That means I would have 36 rungs if I had 108 toothpicks. Now, what if I had 53 toothpicks? Again, we know the rule. It gave it to us. How would I write that? Well, I would write that as 3r plus 2 equals 53. And it really doesn't matter if you put 53 first or last, as long as it's on the other side of the equal sign. Now, do your backtracking to solve. First thing I did to the variable is I times by 3. Then I added 2, all to get to 53. Now, undo it. Subtract 2. Gets me to 51. Divided by 3 gets me to 17. That means I have 17 rungs if I have 53 toothpicks. Now let's look at the pattern with these toothpicks. Again, this time it gave us a table we can fill out to find the rule. So when I have 1 trapezoid, I have 5 toothpicks. When I have 2 trapezoids, I had 9 toothpicks. When I had 3 trapezoids, I had 13 toothpicks. Now remember to find the rule. It's the change between them because the inputs are consecutive. They're in order. So the change is 4. That's my multiplier. That goes with my input. So 4t, how do I adjust it to make sure it's going to equal n? Substitute in a number. By substituting 2 for t, 4 times 2 is 8. What do I have to do to get to 9? I have to add 1. There's my rule. Now if I had 125 toothpicks, how would I write an equation? Well, toothpicks is represented by n. So I would write that 4t plus 1 equals 125. Then I would use my backtracking to solve. The first thing I did to the variable was times 4. Then I added 1, all to get to 125. Now backtrack it. The opposite of plus 1 is minus 1. That gives me 124. The opposite of times 4 is divide by 4. That gives me 31. That means I would have 31 trapezoids. Get in the habit of labeling. Whether you abbreviate or not, make sure you're labeling. Now let's look at this table. I don't have consecutive inputs. Remember, that's always on top. Then I have to get to the output. So I have to look, what did I do from the top to get to the bottom? Well, the first thing I look is at 0. What can I do to 0 to get to 19? Well, I can add 19 to it. There's nothing I can really multiply 0 by or divide 0 by, and I can't really subtract anything, so I know I have to have plus 19 somewhere. But if I add 19 to 3, that does not give me 20. In order to get to 20, somehow I got to make that 3 equal to 1. What could I do to that 3 to make it equal to 1? Well, think about it. I would need to divide something. If I did 3 divided by 3, that equals 1. And 1 plus 19 does equal 20. Does it work for 6? The 6 divided by 3 equals 2. 2 plus 19 gives me 21. There's my rule. Input divided by 3 plus 19 equals my output y, because 0 divided by 3 would just be 0 plus 19. Now write an equation where y is 55. That'd be n divided by 3 plus 19 equals 55. Use your backtracking to solve. What did you do to that variable first? I divided it by 3. Then I added 19, all to get to 55. Remember, if you're having trouble knowing how many circles, count how many numbers I have in my problem. That tells me how many circles. I have 3 numbers in that problem, 3, 19, and 55. Then I know I need 3 circles. Now backtrack it. The opposite of plus 19 is minus 19. 55 minus 19 is 36. Then I need the opposite of divide by 3 is times, I'm making a very good time sign there, times 3, which gives me 108. This time n equals 108. Now we can use these in real life as well. We have Legog made candy apples to sell at the farmer's market on Saturday. He makes a profit of 35 cents per apple. That's how much he's going to pay after he pays all that's expensive. That's what a profit is. We want to write a rule for that. Well, if I'm going to make 35 cents for every apple I sell as a profit, I could say that n equals 0.35. Oh, I'm sorry, not 35. I want to label that first. Let's put that n is the number of apples sold. Okay, apples sold. And then I can say P equals my profit. That's how much money I'm going to make. This is what companies use to determine how much money they're going to make for things. Now, if I'm making 35 cents per apple to find out my profit. So how many ever apples if I multiply by 35 cents, that's my profit. Now I need to make at least $8 to go to the movies. So a profit has to be $8. So 30.5n equals 8. How many apples do I need to sell? Well, if I backtrack this out, I only need 2 because I only have 2 numbers. 0.35 to get to 8, divide by 0.35 gives me what? Well, if I divide that out, I get 22.8. How many apples would I need to sell to make sure I still have my $8? Well, I can't sell 0.8 of an apple. If I only sold 22, that wouldn't be enough. So I have to sell 23 apples. Sometimes you'll see this written as inequalities, where you could have 0.35 per apple has to be greater than or equal to $8. That means I have to make at least $8, but I could make more if I needed to. And the process for solving and backtracking is the same. How about if you have a plumber come to your house? He charges $45 for the house call plus $40 for each hour. Remember, when you're looking for keywords such as each, per, every, those are the things that indicate the variable goes with the number right before that. So if I was going to write a rule, $45 is what they charge me to come to my house, plus $40 for every hour. N is my variable there. To write an equation, if my bill was $105, I would write 45 plus 40n equals 105. How long were they at my house? If I go ahead and do my backtracking, I multiplied by 40, then I added 45 to get to 105. If I backtrack it out, I have to subtract 45 to get to 60, and then I have to divide that by 40. Do not forget, when you divide now, I have 1.5 is what comes in my calculator. Well, 0.5 just means half. So they were there 1 1/2 hours. You could write that as 1.5 hours. That means the exact same thing. Just make sure you're labeled. Here's another one. You hire a taxi driver. You're usually charged a fixed amount of money when the ride starts, plus an amount that depends on how far you travel. The taxi driver charges you $2 plus 75 cents for every quarter mile. That's important to realize. It's quarter mile. I want to know how far I can go on $20. Well, I don't say I went 5 quarter miles when I tell somebody how far I went. I say how many miles I went. So I need to figure out how much they're going to charge me per mile. So the first thing I would take is that 75 cents times 4, because there's 4 quarters in one, which means $3 per mile. That's what they're really charging me, is $3 for every mile. That'll help me in my equation, because it's $2 to start out plus $3 for every mile. And I went, how far did I go for $20? Again, use your backtracking. to solve. All right, I want to get to $20. I times by 3 first, then I added 2. Undo it. Subtract 2, get to 18, and then divide by 3. I went 6 miles. Make sure we're looking for these key things. This is how they try to trick us, by putting in that quarter mile. So pay attention to that when reading the problems. Next one is Caroline and Athena are making a kite. The materials for the main part of the kite are $4.50, and then you pay 9 cents per yard. How much can I buy for my $30? Well, if I read an equation, it's $4.50 for the main part, plus 9 cents. 9 cents is written as 0.09. N equals 30. Or write this as an inequality. $4.50 plus the 9 cents, written the same way, has to be less than or equal to $30, because that's all I have. I cannot spend more than my $30. And then backtrack it out. The backtracking works the exact same way. I multiplied by 0.09, do not forget that decimal point, and then I added $4.50 to get to my $30. If you subtract $4.50, you get $25.50. Then if I divide by 0.09, I get 283.3 repeating yards. Well, I can't buy more than what I have, so I can't round up. So my answer would be 283 yards would be the most I would be able to buy without going over my $30. All right, give this a try. Remember, pages 6 and 7 are due on Wednesday.